OmniScan RollerFORM setup and configuration for CFRP panels. Start with File New to clear out all existing configurations and navigate to the wizard and Part and Weld. Enter the component thickness and select composite material for a default velocity of 3,000 meters per second. Select Next, Next, and Finish. Continue the wizard in the setup. Select PA group mode. In this case, you'll see different configurations or different options here depending on the module and instrument configuration. This is a phased array inspection. And we'll use a 0-degree technique to shortcut some of the setup for default 0-degree parameters in the C-scan and gates. With auto detect on, the probe parameters are automatically detected. This is a 3.5 megahertz linear array, 64 elements, and designed for near wall inspection to be used with the RollerFORM. Select the RollerFORM from the database, and this is a water wedge with a 25 millimeter standoff and the offset set for near wall inspection. The skew is the beam orientation relative to the mechanical movement of the scanner. Leave it at default 90 and continue to the focal law creation. We selected linear at 0 degrees and it locks in this option. We're on the first leg. We'll use a default element count of 4 elements per A scan or aperture. This can be increased depending on the thickness of the component and best results. Start element 1, and this is a 64 element probe, and we'll use the entire probe. Okay, every A scan is going to step 1 millimeter and select a shallow focal depth. Enter gate A position to start at about 1.5 to 2 millimeters. We want the gate to be as close to the surface interface signal as possible, and we'll adjust this during our UT optimization. So at this point, the group and all of the focal laws have been created. Let's go to our UT menu and enter a gate position of -2 millimeters for now, so we can see this is the tire material or wheel probe interface to the component. This would water here, and here is our back wall barely visible. The synchronization gate, the yellow gate, is used similar to an immersion tank, and it has a function called synchronization on echo. It will dynamically adjust the position of all A scans or focal laws to 0 millimeters so that as the probe is moved and pressure changed, the interface will stay straight and flat. So we'll switch to synchronization on echo. At this point, no wedge delay is stored because it's dynamically adjusted, and as I move the probe now, my interface is flat regardless of if the probe is even or not. We're going to use the first peak of the signal in the gate and edge mode, and it's normal that the yellow synchronization gate is not visible while we're in this mode. And we will change the same measure modes for our detection gate A. Select the position . So we'll go to our UT configuration, enter a short range. We want enough range to cover the back wall of the component plus a few more millimeters. Under the pulsar, select the appropriate voltage that gives best results. In this case, we'll select the medium at 80. For the receiver, we're going to turn off the video filter. Select half wave rectified negative, and reduce the amplitude until the interface signal is approximately 75 to 100% amplitude. And as I move the wheel probe, I see it's stable and flat. Under the Advanced menu, select Auto. This will ensure a low compression and scale factor for optimum results. And we'll tweak our range so that we can see just a little bit of the water interface, or the water column here, and the interface. Here is our back wall of the component. We want to increase the amplitude of the back wall without increasing the amplitude of the interface signal, because that will hurt our surface resolution. So we'll do that by creating a manual TCG. The first point of the TCG is always present and visible at 0, and we're going to move that just off the interface signal, so when we raise the gain, it won't interfere with our interface. Select Add Point and move the point to the position of the back wall and increase the gain until the back wall is approximately 75% to 100% amplitude. We'll tweak our detection gate. We want the gate A to be within about 1 millimeter or half or so of the surface interface, and long enough to cover the complete back wall of the component. Ensure that we're in first peak and edge mode. We'll enable the C-scan. At this point we're on time, so we'll see a scrolling C-scan. We'll enter a thickness for the component of about 1 millimeters to 10. And we will use the A minus I reading for our readings and for the color palette. At this point, the UT, the C-scan, and the S-scan have been set up for the inspection. We'll save our file. And we'll continue to the next section for encoder and inspection preparation.